to your Stoichiometry podcast. We have already gone through how to calculate molar mass and how to do mole conversions. And stoichiometry may sound like a scary word, but it's really just a fancy way of saying we're adding one more tiny conversion factor so that we can start with one substance and find out how much of another we can produce as a result of a reaction. As you guys know, I really like snowboarding, and I think stoichiometry is one of those times where we can actually pull in a pretty decent snowboarding analogy to figure out what the heck stoichiometry is. So as I said on the last screen, stoichiometry is kind of like a recipe where you have a certain number of things that you put together and you can form a certain number of products. So if I wanted to make a complete setup for a snowboard, I'm going to need bindings. I'm going to need bolts to secure the bindings to a board. So I need those three pieces to make one complete snowboard. So we can kind of look at this as a chemical equation where we have bindings plus a board plus bolts equal a snowboard. As you know, or maybe you don't, and this is new to you, you can't just throw together a random number of each of these things and wind up with one complete set of snowboards. These work in proportions. So to make one complete snowboard, assuming I have 2 feet, I'm going to need 2 bindings. And assuming I would like those bindings actually secured to the one board that I'm going to ride, not more than one, I'm going to need bolts for that. And we're just going to assume that those bindings require 4 bolts apiece times 2 feet. So I need a total of 8 bolts. So let's go ahead and use those numbers as our coefficients for our reactants or for the bindings, board, and bolts. So I need 2 bindings plus 1 board plus 8 bolts. That's going to give me one complete snowboard. So far, you're seeing that this kind of looks like a chemical equation. This is not stoichiometry. Where it becomes stoichiometry is if I told you, okay, I have 24 bolts. If I had unlimited amounts of everything else, how many snowboards could I make? And I'm sure you just did that math in your head, but let's put it into a T-chart because this is going to get more complex than snowboarding, unfortunately. So let's start with these 24 bolts, and they want to know how many snowboards can I build. So I know I'm starting with 24 bolts. Okay. And what I have to do is I have to look at my ratio of bolts to snowboards. So in order to make, and I'm going to use this coefficient, 1 snowboard, I'm going to need 8 bolts. That's a numerical equivalent. 1 snowboard requires 8 bolts. Okay, my bolts, I know this is funky, but those bolts are going to cancel as units, leaving me with snowboard, which is exactly what I was asked for. So to complete this T-chart, 24 times 1 is 24 divided by 8 gives me a total of, 4. It's not 4, it's 3. Come on, McCann. It's going to give me a total of 3 snowboards. That's assuming I have as many of the other ingredients or pieces that I require to make this. So if 24 bolts is all I have, I know I can make a total of 3 snowboards with those ratios. So what we did is we used the ratio of snowboards to bolts, those coefficients in front of there, to figure out how many snowboards we could build. So that is essentially stoichiometry. Let's apply this to our actual chemistry and chemical reactions. So what we're doing is we're creating these problems from balanced equations. So if I want to convert grams of reactant to grams of product, notice that the substance is changing. I'm going to have to use stoichiometry to do that. And in our previous example, we went from bolts to snowboards. We converted the reactants to the products in order to figure out, using a ratio, how many we could produce. So this is going to require an understanding of mole ratios in order for you to do this. For example, let's take the balanced equation. So if you're struggling with writing neutral compounds and balancing equations and predicting products, you need to get good at that before we can be good at stoichiometry. So go back and review that. Sodium plus chloride gives me sodium chloride. And I know that it requires 2 sodiums, the diatomic element chlorine, to make 2 complete sodium chloride molecules. So those are ratios to each other. When I'm looking at this, I want you to think of the coefficient as saying I have 2 moles of sodium and 1 mole of chlorine and 2 moles of sodium chloride. That's where we get our mole ratios from, is those coefficients. So your coefficient is equal to the number of moles for that substance that the coefficient is in front of. Don't get overwhelmed by what I'm about to just show you. We're going to talk through this. Okay, so there are a lot of possible conversion factors or mole ratios. Holy mackerel, that's a lot. Let's just talk through it. So if I wanted to compare moles of sodium to moles of chlorine, okay, I can go back to my balanced equation. Let's use a different color. And I can say I have 2 moles of sodium per every 1 mole of Cl2. That is a ratio. That is now a conversion factor that I can use in a problem to convert from, we would be canceling chlorine and winding up with sodium as our product. Okay, so I can use those to convert from one substance to another using my balanced equation. I could also flip that around and say 1 mole of chlorine is equivalent to 2 moles of sodium. Or I can compare reactants to products. 2 moles, and I got this 2 from my balanced equation, 2 moles of sodium chloride is equivalent to 1 mole of Cl2. And I can flip those around. So I can compare every substance here based on their coefficients or their mole ratios. All right, let's start by talking through the process, and then on the next slide we'll go through a practice problem and we'll work through the process that we've outlined. So the first step, as I've kind of alluded to, is you have to be able to write a balanced equation. If this is challenging for you, this is something you need to go back and review. You're going to then determine what your known is, so what's given in the problem, and then you're going to have to figure out where to end. So what is the problem asking me to find? What is the unit? What is the substance? Because that's going to guide what conversion factors you choose to use along the way. Finally, when you know where to end and you know what you're starting with, you're going to be able to determine what ratios you need to get there. You may need gram to mole ratios or conversion factors. As you remember, mole ratio is in the unit moles. So if you're given a known that's grams, you're going to have to first convert that to moles using the molar mass before you can look at a mole ratio to change substances. So generally speaking, grams to moles, that will be your first conversion. Second conversion is a mole ratio. And then depending on what they ask you for where to end, they could say how many moles are produced and you're done, or they could say how many grams are produced of the desired product, in which case you'd have to then take your moles that you found and convert to grams. Again, this is a lot easier in practice. So let's try it on the next screen. All right, we got a word problem here. So I'm going to start by underlining my known and circling what it is they're asking me for. So they ask how many moles of chlorine are needed to combine with 0.500 moles of sodium when forming sodium chloride. Okay, so the only number I have here, and I'm going to go ahead and underline that, is 0.500 moles of sodium. That's my known. That's where I'm going to start. They want to know how many moles of chlorine are needed in order to combine with this to form that. So this actually cut off a lot of steps because they're starting in moles. So I don't have that initial gram to mole conversion. So let's go ahead and set up our problem. 0.500 moles, I'm abbreviating, big shortcut there, MOL, moles of sodium. Okay, now I'm changing from moles of one substance to the moles of the other. To do this, I need a mole ratio. To determine the numbers of my mole ratio, I look to my balanced equation. So I know I would like to cancel moles of sodium. So looking at the problem, I have 2 moles of sodium. Notice that moles of sodium and moles of sodium are going to cancel. Well, moles of sodium I can compare to chlorine, moles of chlorine, by looking at the balanced equation. There's no number in front, so I assume that there is 1 mole of Cl2. These guys are in a 2-to-1 ratio in this balanced equation. So what I have done by using this mole ratio step, and this is your mole ratio, this is the stoichiometry, everything else you've already done with mole conversions. This cancels moles of sodium and it leaves me in moles of chlorine. Looking back at my problem, that is exactly what they asked me to find. So now I'm ready to draw my equal sign and calculate. So 0.500 times 1 is 0.500. Divided by 2 gives me 0.250. And I'm going to double check my sig figs. 3, 1, 2, 3 were given in my known in the problem. So I need to maintain 1, 2, 3 sig figs in my final answer. So I have to put that 0 on there for it to be significant. And the units now are moles of Cl2. All right, so that last one was fairly easy in terms of what information they gave us, what we started at, and what we had to convert it to. So we didn't have a ton of conversions. We are now going to do one of the trickiest types of problems. So we're kind of making a little bit of a leap. If you're not ready to make the leap, go start with those simple one-step conversions and then work your way up to it in your guided practice. So we'll start by identifying what our knowns are and what they're trying to get us to find. So how many grams of aluminum are needed to make 24.4 grams of aluminum oxide? Okay. All right. So I am looking for grams of aluminum. This is the question. Are needed to make 24.4 grams of aluminum oxide. All right, so I'm going to have to write a balanced equation. So I know I'm starting with aluminum, and I'm ending with, and I'm just going to do this off to the side so you can see what I'm doing. Al has a +3 charge. O has a -2, so we're going to drop and swap, so it'd be Al2O3. Well, shoot, they didn't say anything about oxygen, but I must be adding this to oxygen if I'm winding up with aluminum oxide. So it's just a simple combination equation. And that is not balanced. I don't have the same, lost my pen. It's good, I found it. I don't have the same number of atoms of each element on each side. So I'm gonna go ahead and balance. Aluminum, we're going to hold off on. Oxygen has 2 on the reactant side, 3 on the product, so I know that 6 is what they have in common. So now we have 6 and 6, and now on the product side I have 4 aluminum, so I'm just going to multiply this by 4. So now I have a balanced equation, so I have a starting point for my mole ratios. So let's go ahead and start with our known. This is going to be a long one, so I'm going to try to give myself enough room. 24.4 grams of aluminum oxide is what I'm starting with. Now that first step in the process tells me that I can't look at a mole ratio from the balanced equation until I get my known into moles. So I'm going to have to do first a gram to mole conversion. So to do that, I'm going to need the molar mass of aluminum oxide, which I would add up 2 aluminums and 3 oxygens, which will give you 102.0 grams of Al2O3, and I'm maintaining number, unit, substance every time. This is why it matters. Okay, so I'm going to be done with grams. I know that that molar mass is equivalent to 1 mole of Al2O3. All right. All right, so my grams of aluminum oxide are going to cancel, leaving me with moles of aluminum oxide. Well, that's great. I have moles of aluminum oxide, but they really want me to eventually convert from moles of aluminum oxide to moles of aluminum so I can then convert to grams of aluminum. And that sounds a little confusing, but let's just try to cancel stuff out. So in order to get to moles of my new substance, because I want to change substances, this step is going to require my mole ratio. And remember, this is where we look at the balanced equation and we use the coefficients for our number of moles. So I would like to cancel moles of aluminum oxide. So that will obviously go on the bottom, so those cancel. And looking at my equation, I see that we have 2 moles in our balanced equation of aluminum oxide. I would like to wind up with moles of aluminum. Looking at my balanced equation, there are 4 moles of aluminum. So see how important it is to have the correct subscripts so you can correctly balance so that you can do these, the stoichiometry problems correctly. It's vitally important. So now moles of aluminum oxide cancel and I am in moles of aluminum. So now I have changed substances using my mole ratio. But they didn't ask me for moles of aluminum. They asked me for grams. So now I have to do one last conversion factor. My God, this is long. And I'm going to convert moles to grams using the molar mass of aluminum. So this last step, I know that 1 mole, I would like to cancel my moles of aluminum, is equivalent to the molar mass, which is 26.98, double checking myself, grams. Awesome. Notice in each box, I have maintained number, unit, substance. Okay, because the units are going to change. You have to be able to track what cancels. The substance now changes. So it's really important that you label that really well, or it's going to get kind of confusing if it isn't already. All right, so now I'm in grams of aluminum. I am done with this equation. All I have to do is multiply across the top. So 24.4 times 1 times 4 times 26.98 gives me 2,633.248. I'm not rounding it because I'm in the middle of a calculation. 102 times 2 times 1, thank God that was easy, is 204. Now I divide the top by the bottom, okay, and I get 12.908 and something. I think that's going to be enough. I need to round this to the correct sig figs. You cannot forget sig figs. After doing all that work, you can't miss points on a silly sig fig issue. So going back to the problem, I see that I have 1, 2, 3 sig figs in my known. So that's what I'm going to maintain. These are conversion factors. You don't include them in your sig fig calculations. So counting left to right, 1, 2, 3, draw my line in the sand. 0 tells me to leave it as it is. So the answer is 12.9. My unit is grams and my substance is aluminum.